Okay, so let's take a look at CD. This is our isochoric cooling. Now from previously, we know that this temperature is 801.2999 something, right? We know that D is at 350 degrees, right? Because it's point A is at 350, and this is an isothermal process, right? So if it's 350 here, it's got to be 350 at the beginning of it, right? Okay. We also furthermore know that the number of moles is 0. Let's find it, 6188757 or something like that. And we figured that out previously, right? That's like the first part of the problem. So we know that, we know this temperature, okay? And so there's two ways really. Oh, by the way, we also know this pressure here too. We know that that pressure at C is 4.57885 times 10 to the 5th pascals. We figured this out previously. So look at the other previous parts of this, right? And so from this, there's two ways we can figure out the delta U. Now, of course, this is just a cooling. It's not, there's no work done on this process. So because the piston doesn't move, the delta, so work is pressure delta V is 0, so work is 0, okay? So once we find delta U, the Q will be the same, because remember this equals this plus that. Q is delta U plus work, right? Okay, so let's figure this out. We'll do it two ways. The first way is to do this, the formula that's in the packet. Not really quite in the packet this way. Our N is 0.6188757. R is still 8.31. And then our change in temperature is final minus initial. So 350 minus 801.299. And this is 3481, negative 3481.45691, okay? Joules. Now, if you want to, we can also find delta U, because see, this is going to be the same as this, right? It's going to be this plus 0, right? So that's the final game there, right? If you don't want to keep watching, I'm going to do it another way. So 3/2, and then it's delta PV, right? Because nRT is going to be, you can either say delta PV or P delta V, right? So we can use this. This is a shortcut, I think. 3/2 doesn't require us to know the moles. Although we kind of had to have the moles to find the pressure. But anyway, let's not worry about that. Okay, so our change in pressure is final minus initial. So the final is 2. The initial is this, right? We got this in a previous part of the problem, right? And then our volume is 99, or 90 minus 3, right? Okay, and let's see if we got that. Yeah, there it is. And then we get exactly the same thing. Negative 3481. Point, exactly the same decimal to 0.45691. Okay, so this guy is negative 3481 is our delta U. That's joules. And then if you add 0 to that, you get negative 3481 joules for the heat. All right. Yeah.